To C3STREAM Land. So today we are going to talk about one of the most famous theorems in the mathematics. I think all of us know about it, is the Pythagoras theorem. We all know that Pythagoras theorem goes like a square plus b square is equal to c square. In the 3 series video, we will just try to prove these theorem in different ways using different techniques or strategies, and we will see why this theorem is why this theorem stands true by 3 different ways. Before we begin, just a fun fact that even before Pythagoras proved that a square plus b square is equal to c square, there were many people like Indian mathematicians. They were using this theorem. It's just that Pythagoras was the first person who was able to prove this, and that's why this theorem is named after him. Okay, so let's begin. So before we begin, I just want to say that I'll be using Mathigan Polypad today. Mathigan is a wonderful website. It also comes in a mobile app. Maybe you can check it out. It's particularly designed for mathematical needs and understandings. So it has all the tools necessary for us to maybe create lesson plan for our students. Okay, so before we begin, I'll just enable the grid. And since Pythagorean theorem stands true specifically for right angle triangle, we will just try to create one right angle triangle using lines. So I have a line tool here, and with here I can choose different colors. So I want this for my base, and as you can see, this gets snapped to my grid. Maybe I'll change the color to pink, and I want this to be 4, and maybe another color, and this is my right angle triangle. I can name this with different sides. So this is my B, side B, and side A, and this can be C. Now I want to see that why this is true. To start with, first let geometrically, okay, I repeat, first let geometrically think what this means. What is the term a squared means? If you think literally, if I ask what is a square to a very young child, maybe he will point to the image of a square, right? This is not exactly a square, but what I drew on the screen, but that is what it literally means. And why don't we start there? So the idea here is to think as if we don't know anything and try to create something out of it. So let's see what kind of square we can create with the side A. And for that, maybe I'll use my polygon tool this time. I can choose a polygon here. That's my polygon. I can bring it here. If I click on a vertex, it just goes away, and I'll snap it to the 2 points, and that gives me maybe 4 units here and 4 units here, and maybe I can give a pink color because it's side A. So that's how my A squared looks like. This is my A square, right? I can also say that this is the area A square is the area of this particular shape with the side length A, right? Similarly, I can create B square using my polygon tool. Maybe I can change the color right away. This is 3 units, so I'll create square of 3 units, and that's my B square right here. But now if I want to create C square, it becomes a little tricky, because first of all, I don't know the length, how exactly this is. It is easy for me to measure A and B, because of the grid line, but it becomes hard for me to measure the length of C. Plus, it will be even harder, since we don't know the length, it will be even harder to create the square. So for that, we're going to need some extra tools, and I can take my old classic ruler. I can snap it to the point, and as you can see, now it enables me to measure the length, which is thankfully exactly 5 units. I'm sure you must have figured that out by now. And I can also use my protractor, and I can snap it here, and this another point allows me to rotate it or scale it. So I'm going to try and snap it to the other vertices like this, which will give me the exactly 90-degree angle. And maybe I can simply take my ruler again like this and put it to exactly 5 units, which will allow me to draw a line, 5-unit line. Maybe I should change the color for that line. So yeah, maybe I can undo, and I can draw another line like this. I can take my ruler, snap it on the other point over here. I can verify my angle, it's 90 degrees, and I can use my line tool to draw another 5-unit line. And now with this, I can delete my ruler, and I can delete my, okay, 1 second, protractor. Okay, and now I have a square or outline of a square with a side length C. I can simply fill it with my polygon. I'm going to just snap the vertices over here to the 4 corners of the outline that I just created. There, we managed to create A square, and we have also managed to create B square and C square. But how do we prove that when we add these areas for these 2 squares, that's exactly equal to this C square? For that, let's do one thing. Let's create a copy of this line. There you go. And let's take these outline aside a little bit. Whoops. Okay. Forgive me. Oh, because it snapped. Okay, we'll have to find some other way. Let's create a triangle instead. Okay, I'm going to use the whole different color for this triangle. And I'm going to try to fit in with the vertices over here. Okay. There we go. And then I want to try and make a copy of this. Okay, let me move my pad a little bit. And I'm going to try and turn it around, so this point will allow me to turn. And it will allow me to snap exactly right outside. And I'm going to surround this outline with the triangles like this. In short, what I'm trying to do is, I'm trying to create another shape which covers or encompasses this square or outline of my square. Let's see if I can do it. There we go, it snaps. Another copy, one more rotation. So can you guess what shape I'm making outside using these 4 right angle triangle? As you can see, I managed to make one square outside C square. So if you can see from this angle, you can imagine that this particular side is made up of A and B. So if this is A and this is B, if this is A and this is B, then because I used the copies of the same triangle and just rotated them, the side lengths, base and height are same. So this becomes B, A, B, A, B, A, right? So now let's think about this arrangement again. Okay, what I'm trying to do is I want to draw a line which outlines this bigger triangle, or bigger square. There we go. It's easier with the mouse than with the... Okay. And I'm going to rearrange my triangles. Okay. Before that, I'll just take my triangles somewhere else. And maybe I'll copy them. These are my triangles. As you can see, that I can still fit my C square inside this. So let's do that. I didn't change the arrangement at all. And okay, somehow the copies were not made. So let me remove this. Okay. And let's make a duplicate. Take them back to the square where it was. And let's fit our C square here. That's my C square. And let's rearrange. We can fit it here. It's the same thing. And we can rearrange this particular square. I'm just going to make sure one thing, that these triangles do not leave the border of my bigger square, right? And as you can see, when I rearrange them, you can see 2 empty spaces which look very similar to the 2 squares that we created, A square and B square. So let's take and see if these squares fit inside our new arrangement. So B square goes in place of smaller square, and as you can see, it fits perfectly, and A square fits perfectly here. The only thing that I changed here is the placement of these 4 triangles. I did not add any element, I did not remove any element. So basically, this visually proves that the area for A square and B square, when we add it together, so when I add this area and this area together, it basically adds up to this area. So this is my A square, sorry, this is my B square actually. So this is my B square, this is my A square. So A square plus B square comes to C square. And here is my first proof of Pythagorean theorem. I hope you understood it. You can try it using Mathignan Polypad yourself. Let me know if you face any difficulties or if you discovered something new. And we will see you in the next video, where we'll try to prove the Pythagorean theorem again using some different method. Till then, happy exploring. Bye.